Hello, this is gonna be a second tutorial video for GhGL, creating a shader component for Grasshopper using GhGL, a new function for Rhino work in progress version. And today I'd like to create this kind of Toon shader using GhGL. So basically you have a base geometry to draw with, and you have a parameter like the division of the shadings, like how many shades you have, like here, based on the lightings, and the thickness of the outline based on the normal direction of the meshes, and then the ambient multiplier. So more value you have, lighter you get, less value you have, less ambient light you'll get. So this is a component that we're gonna write today. So let's get started. First of all, let's have some geometry to draw with. I mean, could be anything. I'm just gonna create the same things that I showed you. A simple, a spiral wires pipe. So I'm gonna use the range, probably have like 100 numbers here, and move this points to the x direction, multiplying by some numbers here, maybe a maximum of 100, like this. And then let's also move this upward to the z direction with some other value here. Maybe change some numbers parametrically. This. And then rotate this point so that I can make it as a spiral curve. And I also need to make another value here, and maybe change the range of the sliders to maximum to 10, and use pi and rotate, create a rotate spiral point array like this, then use the interpolate curve to create a spiral curve like this. Okay, then finally use the pipe to create a pipe geometry with a thickness or the radius parameter, maybe a maximum of 10 something. Right, that looks pretty easy geometry. I mean, nothing fancy, but good enough to try out our Toon shader. Maybe I also want to have a cap, like a round cap. Okay, that looks good. Now let's try creating a shader then. And what we're gonna use today is a GL mesh shader. In order to use this, you need to install from a package manager. You need to install a GhGL, like you did for the last tutorial video for the madcap shader. Wait for it and search for GhGL, this one. The current version that I'm using is 7.0.4, so that's the version which should work. And I think you need to have a Rhino work in progress, the newest version of Rhino work in progress, in order to use that. So keep that in mind. Now let's connect this pipe into the mesh shader. As a default, you have this magenta diffusion shader, and we're gonna build up some new functions based on this. Okay, first of all, I am going to add some parameters that we're gonna use. 3 parameters. first one, I'm gonna call this div as a division number of how many shades you would like to have for a Toon shader. So it's gonna be an integer. So I'm gonna make an integer sliders here. Now for the y, for the second parameters adding, it's gonna be a thickness. Thickness for the outline, since we're gonna use a outline. The Toon shader. Would like to create a black outline on the outline of the meshes, based on the normal direction of the meshes from compared with the camera direction. I'll explain it later. And the maximum value should be 1, 0 to 1. So create a sliders like that. And then another parameter that I'm gonna add is a ambient. So more value you have, more lighter color you'll get. Right, so I guess I need one more parameter here. Let me add one more, and I'll call this col. So the base color that you would like to use. So I'm just gonna connect the color swatch here. Maybe as any colors you like. You could also use textures, but if you watch the last tutorial video for the matcap and watch this one next, then yeah, I think you can be able to use textures with a Toon shader as well. So for this one, I'm just gonna use with the colors. Right, then I think the setup is good. Let's get into it by double clicking it. Now, first of all, I need to get some information from the mesh in order to calculate some values for the shaders, for the Toon shaders. The first thing I would like to have is the normal direction, which I already have here, so that's good. And I also need to get the camera direction from the camera location to the point, to the mesh vertex direction. So let me write some code here. So what I'd like to do now is that I have this mesh here. Right, and I have this camera here, and what I want to do today is that from the camera view, looking like these, I need to draw a outline on the edge. So from the camera, what I can see is only this part, and I want to draw a edge, the outline edge on the edge of the meshes like this. So in order to detect where the outline should come, what I can do is to simply do a calculation of the dot product between this camera direction, or the eye direction, plus this normal direction of the mesh. So when the camera direction goes like this and the normal direction of the mesh goes like this, and if the dot product of these two vectors are close to 0, which means it's close to perpendicular direction, then you should have some kind of outline edge like this. If you have a dot product between this camera position and this kind of normal, which is a which looks like these. So the angle between those two vectors are not close to perpendicular, then you should avoid creating an outline. So that this is how you can detect where the edge you want to draw in this case. So in order to calculate this kind of value, you need to have a location of the camera as well as the direction of the eye view. So let's go back to the Grasshopper, and then in order to create the direction using the value you can get from this GhGL component, you can retrieve the camera location from the global variable you can get from these menu, and there from the insert built-in uniform you have this camera location, so insert that first. Right now after you got it, the camera location is where the camera is positioned, so you can calculate the direction vector using this location plus the location of the vertex for this mesh. So, and the vertex position of this mesh can be retrieved from this one. It's already being retrieved, so let's calculate eye view, the camera direction, using those two information. And I wanna output this information into the fragment shader later, so I'm gonna create a out vec3 camera direction like this, and the camera direction is equal to normalized. So I want to make a direction to a mesh vertex from the camera location, so mesh vertex minus camera location like this. Okay, that should be good. And I think that's the all the information I need to create on the vertex shader. Now let's go to the fragment shader in order to use those information to create some values. Right, first of all, in the fragment shader, I want to have an input of those parameters that I have created as an input. So let's first register those values. First of all, a division. I'm gonna create somewhere around here, so, or maybe a bit upward, somewhere around here. Okay, so uniform float div, as well as uniform vec4 col, which is a color, RGB and alpha, and uniform float thickness in order to use it for the thickness of the outline, and uniform and float ambient, so the ambient strength for the Toon shader. Right, and also I have I would like to transfer this camera direction to a fragment shader from the vertex shader. So create a in vec3 camera direction to communicate with it, to retrieve the value from the vertex shader. All right. Now I am going to reuse some of the code from the template written here. And first of all, I want to change the base color from magenta to the color that I have loaded, which is green right now. So I can do that with replacing this one, this is where you are drawing a magenta color, creating a magenta color. So I'm gonna just replace this with cull first, right? And nothing seems to happen. What is there any errors here? Okay. All right. I guess I needed to update the component. So this seems to work. Now it's not still a Toon shaded. Let's go back to the code and go to the fragment shader. Now, next thing I would like to do is to create a Toon shader looking value from this gradient color. So in order to do that, first of all, let's test out which kind of value I could use in order to create a Toon shader. So if I look at this intensity value here, which is the dot product between the normalized light direction as well as the camera normal here. Let's check. Let's check by, so the intensity is float, so I'm gonna convert this into vec3 here. Intensity. What did I? Vec3. Now that gives kind of a really blacked out value here. I guess it's because the value is in between -1 to 1. So let's make an absolute value of the intensity to see what it looks like. And this looks more like a shaded version of the value. And I guess I could use this to create a Toon shaded value based on this value. So in order to do that, what I could do, I could first use this division value in order to divide this gradient value from 0 to 1, since this is black to white. So divide those black to white gradient value, which is from 0 to 1, with some integer value, like which is around like 2 to 3, 2 to 10, and divide those gradient into the ranges, and then for each ranges just use the constant value. So let's do that by creating a, I'm just gonna call diff equals to absolute of intensity, I multiply by division, and then make it an integer using something like a round, and divide it with division value again, and then use this diff to actually visualize as a black and white value and see how it looks like. Diff, and yep, it already looks like a Toon shaded color. And if I change the division value here, you can see that the number of division has been changed based on this number, and that is looking good. Now I want to also now that I have a black and white Toon shade here, I want to use this with this color that I have imported. So So the diffuse is color here, right? So if I change this to diffuse XYZ, then I will have the whole green stuff. So maybe I could create a vec3 call and use the mix function for the OpenGL, GLSL. And then when the value, this diff value is 0, then I would like to have maybe a black color. And then when the value diff is equal to 1, then I would like to have a color, which is a diffuse, which I've imported here, green. So the black color can be written like vec3 0, 0. Then the gold color, diffuse. I just need the X, Y, and Z. X, Y, and Z. I don't need the alpha here. And then use diff. Right, and let's replace this with col and see what happens. And yeah, seems like this is the one I would like to get. Now, this is always gonna be from black to this original green value, the inputted green value. So the darkest color will be always black in this case. And this is where I would like to use the ambient value. So when the ambient is close to 1, then the darkest color will be same as this magenta color. And if the ambient is equal to 0, then I would like the darkest color to be black. So that's where I would like to use the ambient. So, and I have a double name called ambient here as well as vec3 here, so I need to just change this value a little bit. Maybe I shouldn't have named this ambient, or maybe I should rename this to something different. Let's say ambient call and ambient call here. Right. And right now the ambient color is starting from just using a fixed number, constant value, which is 0.1 in order to create an ambient. So let's replace that to something different. And I don't think I'm going to use this one, so I'm gonna comment this out. And for these 0.1, I am going to replace this with the value I have imported, which is this ambient float value, which is this one. So replace this with ambient, ambient, and ambient, and let's test out. Let's see what this looks like when I output it as a color. So replace this col with the ambient col. And if I change this ambient value, it goes from black to the magenta like this. So that's good. Now, the next thing I would like to do is to replace this black value that I have used in this mix function with this ambient col. What we have created. What we just have created. So ambient col. Alright, then replace this again with the col. And now the darkest color of the Toon shader, the Toon shade, will become equal to this ambient color value here. Alright, that looks exactly what I wanted. Looks like exactly what I wanted to have. Nice. Now, so far so good. Now that as addition, I would like to have an outline to this mesh to complete it as a Toon shader. So let's do that. I'm just gonna delete this thing. And for Toon shader, I am going to use this camera direction, which I have imported from the vertex shader. So let's do that. So just before fragment color updating, I'm gonna calculate the dot product between the camera direction with the mesh normal. So let's call this dot val equal to a dot product of the normal of the mesh plus camera direction. And the dot product in this case the range will become -1 to 1, and so I am going to make an absolute value here. Right. Now let's also check this dot value by setting it into a color to see how it looks like. So vec3 dot val, and right now the value of this dot product looks like this. So the black part is where the dot product between the camera direction and the mesh normal is close to perpendicular. See, like those edges. So those are the places where I would like to make it as black outline. So in order to convert this value to some black and white value, the easiest function I could use is to use step function. So if I use .val equals step and use some threshold here as a first number, then .val as a second number, you could have a value like this. So in this case, when the value is less than 0.25, then make it black, make it 0. If the value is greater than 0.25, then convert it into 1.0. So if I change this to 0.5, the outline should become bigger like this. And if I make it close to 1, then try to convert it into whole black part. So this is where I want to use this thickness input that I have imported here. So let's connect this thickness into a step, the first value of the step. If I change this, see that I can control the outline of this shader. Alright, that looks good. Now that I have this outline color, which is black and white, and then also the shaded color, Toon shaded color, which could be any color, what I could do now is to just update the color, multiply by this dot value, since if you multiply the color with 0, then it will always become black. If you multiply the color with 1, then you always get the original color. So this is how you can blend the color with the outline. Then finally I'll put the completed color. And voila, you'll have a combination between Toon shader and outline, which you can control the outline thickness, the division of the shade, and some ambient. And that's it. That's how you can create a Toon simple Toon shader, the Toon shader component using GhGL, and the knowledge that you have gained here can be used in any like platform using OpenGL, using GLSL language. So the information is pretty global, not just fixed to Grasshopper. But this is how you can create a Grasshopper component using GhGL, which is a great features that I think. Right. So this is it for creating a Toon shader. I hope you like it. I like it myself. Think I could use it for I don't know, some kind of easy presentation, or have joy of having a cute geometry shown while I'm do a modeling, maybe. Alright, that's it. Thank you for watching.